Hi everyone, this is going to be the second video for day 3, week 3. Short video, we're going to look at some of the very simple scenarios of plotting in polar coordinate system. And then the next video would be more complicated examples. So usually we will be plotting in the same rectangular system in the sense that we're still going to have x and y, but just to sort of give you an idea of what the actual axes look like or the variables look like in this system, that's the sort of grid we will be using, where the dotted ones are the variable r, right? So this would be like, say, r1, r2, r3. And these outward going lines are going to be certain values of theta. So as you see, if I pick this theta equals theta 1 and I travel along this line, no matter what point I pick, my angle is going to be the same. But my distance r keeps on changing. Whereas if I move along this dotted line, my r, or the distance from the center, remains the same, but my angle is going to keep on changing. So those two movements are like moving along the x-axis and moving along the y-axis. So moving along the r-axis would mean that we are on this line, constant angle. And moving along the theta axis would mean we're jumping from one circle to the next. So let's see. Sketch a graph for the equation r equals 3. Now one way to do that is direct. We just said that if r is 3, what that means is these are all points which are at a distance 3 from the center. And if you think about it, that's going to be a circle with radius 3. Because those are all points that are at the equal distance of 3 from the center. But we can also use this relation that r is square root of x squared plus y squared, and then we square both sides, yielding x squared plus y squared equals 9. And this, you know, from Math 103 is the equation of a circle with center at 0, 0 and radius equals 3. So they sort of match up. Now the next one, graph the equation theta equals pi over 3. Now what this means is these are all points which have an angle of pi over 3. The distance may vary. So that's going to look like this straight line where this angle is pi over 3. Now how do I obtain this equation? Tan theta is y over x. So tan of pi over 3 is y over x. And what's tangent of pi over 3? Tan pi over 3 is actually root 3 over 2. So root 3 over 2 equals y over x. You cross multiply and you get y equals root 3 over 2x. Now there is also a direct way to get this. If this is a straight line, remember that tangent of this angle it makes is the slope of this line, which is root 3 over 2. So you can also use y equals mx because it goes through the origin, which gives you the exact same result. So the point here, this short video, is to show that if you fix r and you let the angle vary, you're gonna get a shape which is circular. If you fix the angle and you let the radius vary, then you're gonna get a straight line. So in the following video, we're gonna look at more complicated relationships between r and theta and how they change with respect to each other and how we can get interesting shapes and what sort of tricks and what sort of tools to use in order to graph polar equations. That's it for this video.